Good morning. Today we are going to discuss about type conversion and casting. So what is type conversion and casting is? So if you want to convert from one data type to the another data type, then the conversion is called as that is called a type conversion. So basically, this type of type conversion can be automatic when it meets two conditions. So what are the two conditions to be met is the first one is the two types must be compatible. That is, there must be some kind of similarity between the two data types. Second one is the destination type should be always larger than the source type. So this particular condition, when we doing the conversion is called as the widening conversion. Why it is called as widening conversion is we are converting smaller data to the larger. That is where the destination is larger than the source. That's why this is called as the widening conversion. So next topic we're going to discuss that is casting incompatible types. So what is meant to casting? There is no similarity between the two data types, then automatic type conversion is not at all possible. So for example, if you want to store a int value to byte, it is not true. Why? Because int size is 32 bit and byte is only 8 bits. So our destination is smaller than the destination is smaller than the source. That's why it is automatic type conversion is not possible. So that is compulsory. We need to do some kind of conversion. Then if forcefully if you want to convert, automatically not possible. We have to perform the conversion automatically. So that kind of automatic conversion is called as the narrowing conversion. Non-automatic conversion is called as the narrowing conversion. So here what is narrowing conversion is simple. We have int a and we have one variable byte b. And if we want to assign the a value to b, it is not directly possible, automatically not possible. Non-automatically we need to perform that. So our whatever the destination is our is byte and our source is integer. So we need to clearly mention within the brackets what are the conversion we want to do. So we want to convert integer to the byte. So like for that we have to write byte of. So whatever the destination type, that data type we need to put in the brackets. Then the compiler will convert the a value to the byte. Then it stores the particular byte value to the b. So this conversion is called as narrowing. Why? Because so we are storing larger value to smaller. That's why it's called as narrowing conversion. And previous automatic conversion is called as widening conversion. Let us take this pictorial picture for better understanding. Here I have an integer that is 32 bit and I have a long that is 64 bit. Now, for example, if you want to store an integer into the long value, it is automatically converted. Why? Because here the integer size is only 32 bits and our long size is 64 bits. So what is the, when we can perform widening conversion is the condition is two types must be compatible. It integer long are both numeric values only. So there is no problem with no problem. That's why we can automatically store 32-bit integer into 64-bit long value. So widening is possible. What is narrowing conversion is our long. Our long is 64-bit size and our integer is 32-bit size. If you want to store a 64 into 32, automatically it is not possible. So that's why we need to perform narrowing conversion. So in narrowing conversion, that's what I told. Whatever the destination type, that type we need to put here. I is integer, that's why I put the int in brackets. So then compiler will convert the long value to integer, and integer will be stored into the this particular I variable. So this is called as the narrowing conversion. So next topic, when automatic type conversion is possible. Very simple. By this particular diagram, very simple you can store. The byte 8 bit can automatically store into short. Why? Because 16 bit. The 16 bit short can be automatically stored into integer. And the 62 bit, 32 bit integer can automatically store into 64 bit long. Again, the long 64 bit can be stored into 32 bit. But here you may get some kind of confusion. You may get confusion. Why the 60? How we can start? You told that the 64 bit is automatic type conversion always our destination. Here our destination is 32 bit and the source is 64 bit. But what is the difference here is the float follows a different kind of representation. That's why the range of float is larger than the long. The amount of data what we can store in the long, it is larger than the float. Why? Because float follows some IEEE representation format to store the data. That's why the long 64 bit can be easily stored into float 32 bit due to different representation what we can. The range capacity of the float is more than the long. Next, after that, the float 32 bit can be automatically stored into double. So these conversions I can explain with simple diagram, then you can understand very easily. Now see, in we'll have some simple store this particular program as con. Now see, for example, here I have two variables. Int a is equal to 355 and I have byte b is equal to, I have a variable byte b. Now we try to store this data, then we can print. Now for example, so I say in byte b is equal to 23 and create one more integer variable int c. Now what we try to do is the C value, C is going to assign with the byte value and try to print that particular variable, and C value is, so C value is, so it's print the C value. Now just check whether automatically it is possible or not. Now what we are doing is the byte variable b we are storing into the int. So here type compatibility, the both are integer category only. So it can be done. What, let us see whether just compile this program and try to execute it, whether it is successful or not. So now I execute it, now it is printing C values to no problem. So byte can be automatically stored into the C. Why? Because C is integer, its size is 32-bit and byte B its size is 8-bit. So 8-bit data directly can store into the 32-bit integer. But if you try to do this statement, check whether, now what we are doing is I am assigning B is equal to A. So let's have 34 here, the 345. Small issue is there. I will discuss that point later. So now A is 34. Now try to store the integer value A into the byte variable B. Now see, let us think what is happened with this particular one. Whether compile is going to generate issue or not. Yes. See here, it is telling that incompatible types possibly loss of conversion from int to byte. So what is happening is here A is that integer 32-bit and byte is 8-bit. So 32-bit data, if you try to store in the byte, what is telling is you may lose the data automatically. So 32-bit information, if you try to store 8-bit, automatically we may lose some information. So it is lossy conversion. So it is not should be happen. So how we can avoid that is we have to convert this particular integer variable into byte first. Then we have to store into the byte. Why? Because here we have to do a conversion call. If automatic is not possible, we have to go to non-automatic. What is non-automatic? Widening conversion. That's why we need to write b is equal to byte of a. Now compile the program. There is no issue. Program is successfully compiled. And one statement is just I need to print that particular value. Now try to print that particular b variable. Now no issue. Now I compiled. Now it is clearly printing C value is 23 and here B again I compile. So if I again B value is automatically it will show us 34. B value 34. So how we can store the integer value byte is by performing a conversion called as the widening conversion. So let us see the next topic. And also next topic, what is next topic is reduced modulo. What is meant by reduced modulo is, for example, see here I have a variable byte variable b and I have integer variable 257. If I, and I also have a double value 323. If I need to store this particular integer variable into byte b, and if I store so what will be the output? So what is the I value? I value is 257. For the respective B value, how much? 257 only. Why? Because clearly we are performing here narrowing conversion. here clearly we are performing narrowing conversion, so no problem, integer value translate to byte and byte, so compile issue will not be there. And after that we again we are converting the double variable d into byte and storing into base, so here also no problem. So what we are expecting from this particular program is, if the b is going to print the value 257 and the double value we're going to get is 323. Why? Because our fraction part 1. But let us check through programming part what is the output of this part. But according to our knowledge up to now, what is the output we are expecting is, we are expecting 257 and we are expecting 323. Let's programmatically see whether what is the output we are going to get about this particular program. What is that? Integer value 257, and we need byte variable, but it should be empty, and make this particular c as a double variable. Double c is equal to 323.142. And now here what we try to do is, we will assign b is equal to I, and we convert that particular into byte type. Why? Because I size is more, and here also let us print that, first of all print that particular values. So I value is a plus a value is a, and byte b value is plus b. So that's all. And again now convert it, now convert double. So here also write byte of and write d. So again what we're doing is, we're converting double variable c. The same c variable are converting to byte and storing into the b. So now try to print that particular one. Now c value is c and b value is. So let us see the output of this particular program. And first of all, we try to compile the program. First of all, we try to compile, then we can see what is going to be happening. So it is showing here some error. Why? Because I have written I. So it is A. We have to write B is equal to A. Then recompile it. So there are no errors. Now try to execute the program. It is showing A value is 257B and okay, but byte value is showing as 1. C value is 323.42, okay, but B value is 67. What happened? So I stored 257 into the byte, but it's giving me 1. I stored 323 to give me 67. What is the reason? Let us see this particular diagram, then you can understand. Here what is going to happen is, so the b value for integer giving 1, for byte is giving, for double it is giving to 67. Why it is happened is, here there is a concept called as reduced modulo is going to happen. What is this particular reduced modulo is? So what a reduced modulo is, basically the byte capacity is positively from 0 to 127, negatively from minus 128 to 0. So for example, if you store more than 127 any value, it is going to occupy. It is going to occupy from the negative side. For example, if you store a positive value 128, if you want to store positive value 128, the 128 will be given minus 128. And if you try to store 256, it is going to store at the 0th location. Why? Because the capacity 256. So for 257, what is happened is, started again from 0, that is 1. Simply what is happened is, to store the larger values, it performs a simple condition. The value, for example, you want to store a into the byte variable, it performs A mod 256. It performs a simple operation A mod. What is the simply? So 257 mod 256 is how much? 1. So that's why the one value is stored. So that's why this concept is called as reduced modulo. What is reduced modulo is basically the byte ranges is from minus 128 to 127. If you try to store the more values, it is first of all more than one, any positive value 127 starts to operate from negative side. More than 256, for 256 it gives 0, 255 it gives minus 1. So if you try to store more than 257, it again start from it. So like the iteration, simply what happens is mod operation. So the mod is going to be worked out here, a mod 256. So this is called as reduced modulo. So next topic is casting incompatible types. So what is casting incompatible types is just we discuss. A different types of conversion will occur when floating point value assigned to a integer. That is, if you assign 123, 1.23 to an integer, what happens? It gives only for us 0.2 will be truncated. So this operation. So whenever incompatible types are casting is performed, some information we may lose. So next topic. So let's welcome to the next topic, that is automatic type promotion in expression. So what is automatic type promotion in expression is byte A is equal to 40. We have byte B is equal to 50, and I have byte C is equal to 100. Now if I write int D is equal to A into B by C, what is going to happen? Here A is byte, B is byte, and C is byte. What happens is there are some rules will be available. So Java automatically promotes each byte short char operand to int. So in a expression, if we have a byte, it is converted to int. If we have a short, it is also converted to int. If we have a char operand, it is also promoted to it while evaluating an expression. These are called as the automatic promotion rules. Next, for example, let us see this particular side. Here I have a statement byte B is equal to 50, and I have B is equal to B into 2. So here what is going to happen is, so I just told in an expression, if you have a byte, it is automatically promoted to integer. What happens here? Byte is promoted to integer. So 2 is also integer. So 2 into 2, 4. So you are going to store the 4 value to the byte. So 4 is integer. We cannot store directly integer to byte. That's why it gives us error. To avoid the error, what we need to do is, before this B into 2, we need to perform casting incompatible type. That's why we need to write byte of. Then there is no problem, and the correct value 100 will be stored into the B variable. So this is next auto. So for understanding of this, let us understand pictorially what are the illegal cast and what are the legal cast. So for example, if you write S is equal to S plus B, it is illegal. Why? Because here B is byte and S is short, but in expression what happened, they promoted to integer. If you want to store directly integer to short, it cannot possible. How we need to write? We need to write like this: S is equal to short of S plus B. Then only after expression is converted into int, then converted again to short. Expression is basically in the form of int. The integer is converted to the short, and short variable is going to store the S variable. S is also short. So if you write S is equal to S plus S also, here S is short, but they automatically promoted to the integer. Now we cannot store an integer variable directly to the short variable. So then also compulsory we need to perform casting of incompatibility, narrowing conversion. That is, before the brackets we need to mention short of. So with respect to sorry, with respect to different mixed ones also, how we need to. So let us see this particular. Here I have an integer and I have a long. Then automatically expression is promoted to the long type. So here also what I am doing is I need to store into the integer. That's why I need to again perform here the long I have. So long I need to convert it into int. I want to store into. Next one here also f plus d. So expression promoted to the double. So again I need to convert into the double to store into the d variable. So again here I have a long plus a floating point value. So I need to store into the long variable. So for that I need to convert to long. So like this we need to perform the operations. So here the type promotion rules are there. All byte, short and char were promoted to the integer. If one operand is long, the whole expression is promoted to the long. If one operand is long, if you, for example, if you have a plus b, if a is long, automatically entire expression b is also promoted to the long only. If one operand is float, the entire expression is promoted to the float. If any of the operands are double, the result is also double. These are the type promotion rules. So a simple program for the understanding. So what here we are doing is, here I have a byte variable b is equal to 42, and I have a c variable assigned a, and the short variable 104. Like that I have the values. So simply what I have done is f into b, like that I done. Here what is the larger one? Double. So entire expression is promoted to double. That's why I can directly store the double expression into the result variable. So in the entire all the variables are promoted double. That's why I can directly store into this particular result variable. So f is promoted to double, byte is promoted double, integer promoted double, carry is promoted to double. So short is also promoted double. That's why our expression is also in the double format. That's why I store into result is a double variable. This is how we can perform typing conversions. Thank you very much.